We've been playing for a while, understanding the fact that the derivative of e to the x is e to the x. That's come in handy a lot of times because it's so simple. You take the original and you just write it again. You don't have to do any arithmetic, let alone math. But what if I have something different? What if I don't want to do this? What if I want, let's say I want the derivative of 5 to the x. Do you know how to do that? It's not the same. E to the x is special. E is a magic number. It's like pi. It's everywhere in nature. That's why it's named after a genius. Okay? It's not anything like 5 to the x. If I want to take the derivative of 5 to the x, we got to think about this for a minute. And we're in the lecture playlist right now. If you found this video randomly, you might want to look at the video before this to learn the chain rule, because that's what we're going to use. If I have an outside function with an inside function, and I want to take its derivative, then I think of this like an M&M. And I'm going to break open the M&M and I'm going to put the chocolate in like this. The outside is the candy-colored shell. The inside is the chocolate. You with me so far? If I want to take the derivative of my M&M, you take the derivative of the outside and leave the original chocolate inside. Then multiply by the derivative of the inside, of the inside there. So here we're changing the outside of the candy shell without bothering the inside. And then we come over and change the inside. So we get a whole new candy. Okay? Okay. So let's get rid of our little stupid M&M example and walk into this thing. Clean that up a little bit. Just because I'm OCD. Is that the right term for it? Crazy is a better one. Remember the chain rule, though, because that's what we're going to use here. And I'm going to remind you of one other thing. E to the ln of smiley face is equal to smiley face. That's from way back in algebra, which you probably skipped if you even saw it at all. But this is important because I can add an e to the natural log into anything. Guess what we're going to do? I'm going to take e to the ln of 5 to the x, and we're going to find the derivative of that. But why? Because this lets us do one special thing. In logarithms, you can take exponents and bring them out. Okay? Why do I care about that? Because if I have an x here instead of here, now the natural log of 5 is just a number. It's like 2.1 or 1.6. It's just a number. And what's the derivative of 5x if I had a 5x? It would just be 5, right? So when we do the chain rule, it says take the derivative of the outside function. Well, that's the original because we have an e to the x function here. So it's e to the x ln 5 times the derivative of the inside function. And what's the derivative of a number as a coefficient for x? It's just the number. And this is the answer. And we can clean this up. Let me show you a better way. Let's remember, if I put this x back up in here, e to the ln of things is just the original thing. So we can write it as 5 to the x times ln of 5. And that is a much cleaner answer. So we put the e's in, and then we took the e's out. This kind of seems pointless until you realize that you arrived at the answer using the chain rule. So let's write it more generally speaking. If I want to take the derivative of any number to the x, then the answer is a to the x times the natural log of its base. And this is the rule that you want to learn. If you can take that with you, we can go over to the problem set playlist and do some practice problems.